In this video, I want to have a look at probability questions that have replacement and some that don't have replacement and have a look at the difference. So in multi-stage probability situations, it's really important to know whether one stage of the experiment is affected by the stage before it. So this depends on whether the item chosen is returned before the next item is chosen. So this is known as selecting either with replacement or without replacement. So let's have a look at what that means with an example to make it a little bit clearer. So in our example, we've got two cards drawn from a set of cards numbered 1 to 5. So we've got our cards here. And we're going to pull two of those cards out to make a 2-digit number. Question 1 asks us to make a list of all possible outcomes if the cards are drawn with replacement and then without replacement. So we're trying to see the difference between those two things. So if we come down the bottom to make our lists, for part 1, we're doing with replacement. So the first card that we draw could be a 1, a 2, a 3, a 4, or a 5. Could be any of those. Now our second card, whichever card we pull out first, we're then going to put it back in the pile, shuffle them up, and then draw a second card. So it would be possible that we could draw, if we draw a 1 first, we could also draw a 1, or we could draw a 1 and then a 2, or a 1 and a 3, or a 1 and a 4, or a 1 and a 5. So because we replaced that card, we could end up with a double-digit number. So a repetition. So in this one, we could have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. And we could do that for all of our numbers. For part 2 of that question, it's asked us to write a new list, but this time we're looking without replacement. So the difference with this is that none of these doubles are going to be possible. For example, if we pulled out a 4 as our first card and we don't put it back and shuffle it around, if we leave that 4 out and we're just drawing from those 4 remaining cards, none of these double ups are possible. So in our list we can have 1, but we can't pick another 1, so it'd only be 1, 2, 1, 3, 1, 4, or 1, 5 that's possible. We could pick a 2 and then a 1. We couldn't pick a 2 and a 2, but we could pick a 2, 3, a 2, 4, or a 2, 5. So we could pick 3, 1, 3, 2. We can't pick 3, 3, but we can pick 3, 4, 3, 5, and so on. Okay, so we have our 2 separate lists depending on whether we replace that first card or not before we draw the second one. So question B asks us if the first card is replaced, so that's looking at this list of numbers, find the probability that the number formed is even. So this is question B, part 1. So in this whole list, this whole sample space, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 even numbers out of a total of, well, we had 5 by 5, so a total of 25. So our probability would be 10 out of 25, but we always want to simplify down if we can, so that would be 2 over 5. For part 2, it asks us to find the probability that the number is greater than 30. So that would be anything in the 40s or 50s, so that's going to be 10 of our numbers out of 25. Oh, hang on, sorry, no, I've read that wrong. Greater than 30, 31 and 32, all those numbers in the 30s are greater than 30 as well. So we've actually got 15 out of 25, which would simplify to 3 over 5. And the last one is divisible by 5. So that's going to be anything ending in a 5 or a 0. We don't have anything ending in a 0, so it's just going to be these 5 numbers along the bottom. So for part 3, we'd have 5 out of 25, which would be 1 over 5 as the probability there. All right, question C says if the first card is not replaced, so this time we're looking at this sample space here, we want to find the probability that the number formed is even. So this is question C, looking at this one. So the even numbers this time we have 1, 2, 3, oop, that should have been a 5, whoops. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have 8 out of, and our sample space this time is 5, but it's only 4 down, so that's only out of 20. So add 8 out of 20, which would give us 2 over 5. Part 2 is find the probability that the number is odd. So if there were 8 even numbers, that means all the rest of the numbers must have been odd. So that's going to give us 12 out of 20, which is equivalent to 3 over 5. And less than 20. So less than 20, all of these numbers are in the 20s, but these 4 here are less than 20 because they're only teens. So we're going to have 4 out of 20, which is equivalent to 1 over 5. All right, so that is having a look at events with and without replacement.